So right, we left it last week, we could get 4 people across a regular bridge in the dark, and they only have one torch. And the question was about the fastest way to get everybody across. I'm going to propose what might be the most obvious solution, but isn't the solution we're looking for. So, given the times that it takes everyone to cross the bridge, and we have to take into account one of the people, somebody that's crossed the bridge, has to go back to the torch so that everybody can get there. Everybody can get back across. And there's a real feeling that journey back time is like dead time. You know, that's a big problem in with our specification. So you might think that the quickest solution is to send, was it Alice? Well, the names Alice, Bob, Carol.
I will be.
And who's the D? Derek?
Yeah.
Oh, what? Well, Alice, Bob, and Carol, you come across a lot. Alice, Bob, and Carol are involved in an awful lot of cryptography problems, where Alice and Bob are trying to send messages to each other, and Carol keeps trying to read them. So if you're ever studying like cryptography or RSA encryption or Diffie-Hellman key exchange, you'll come across Alice, Bob, and Carol a lot. But this is a different Alice, Bob, and Carol. So it might seem that the quickest way to do it is to send Alice across with everybody and have Alice coming back. She only takes a minute to get back across the river. So I guess that would look like all right. So let it be 10 minutes, 1 minute, 5 minutes, 1 minute, and 2 minutes. Right? Now, we made it a little easier with this one by abstracting the components of our problem into 2 things that were found together and 1 thing that wasn't. But the core part of that, and the reason we did that abstraction, was to show the use of symmetry in finding the solution. Although it's a special kind of symmetry, it's more of a mirror symmetry than an exact copy kind of symmetry. Right? And we can apply symmetry to this because as much as we might hate this during back time, it's not where our biggest loss of the time is. Obviously it's that we have someone that takes 5 minutes to get over and someone that takes 10 minutes to get over. So the best way to save time would be can we send the 2 of them over at the same time. That way we save 5 minutes. But of course, somebody has to bring the torch back. So if we send them across, And Carol has to go back with the torch. We haven't saved 5 minutes. We've added 5 minutes because she still has to get back across the river again. So when we send Carol and whoever the hell that was across the river, ideally you would have someone faster on the other side to come back with the torch. So this is a very similar problem. You can see that like our precondition and our postcondition are symmetrical. So it is amenable to the same kind of solution. And we figured, okay, a good thing to do is send these two over together. But we know we have already sent people over, so we'll someone come back with a torch, and they're going to have to go back with a torch because there's someone still to get across. So at this point, this might be where we would send the two slowest people. But there has to be somebody over there waiting, and it's going to be the two fastest people. Okay, we send the two fastest people over, and we end up with two of them on the other side of the river. Now somebody has to bring the torch back. We may as well get Alice to do it. Okay, which means we know the data here. Having swallowed up the second slowest journey into the slowest journey, we can take advantage of the fact that we have one of the fastest people here. So, Bob, we can send Bob back. Out of those times, that should be 17 minutes, is that right? Mm-hmm. So instead we have 2, 1, 10, 2, and 1. I don't think it could be done any better than that. I think that's as fast as it gets. Sure. Yeah. There you go. Just like that. So, now we're getting ready for the first assignment. So, this isn't it. But you need to go through this to do the first assignment. If the president is left in the company of some other president's bodyguard, that bodyguard will whack them. They will be assassinated. A president can be in the company of as many bodyguards as exist, so long as their own bodyguard is there. Presidents won't kill other presidents, bodyguards won't kill other bodyguards, and bodyguards won't kill a president as long as that president's bodyguard is accompanying him. And we have to get them all across the river. In a boat that holds 2 people. So basically, now, how might you even represent that? Say we have, that's a president, and that's a bodyguard. Do we need to do that?
Yeah.
No. We actually don't, and in fact when you do this explodes really badly. You're welcome to try it if you want. But this isn't actually necessary. Because the information that you're embedding in these numbers can be captured with different representations. So if we use P to represent an unaccompanied president, B to represent an unaccompanied bodyguard, and just use C to represent a couple of them together. So our problem then is starting with 3 couple on this side of the river, and then with 3 on that side of the river. So once again, we seem to be looking at a symmetry problem. So given that we have this very tight constraint, we can't leave an unguarded president in the presence of another bodyguard. Where we start is kind of dictated then by the problem specification. Because we have to start sending people across the river. Right? We've got a boat that only goes to, a couple of people have to go across the river in the boat, somebody has to bring the boat back. Yeah.
Does it still apply if, for example, there's an unaccompanied president and an unaccompanied bodyguard in the boat at the same time?
Absolutely. Yes. So since we have to start sending people across the river, we can't start sending bodyguards, because if we send 2 bodyguards across, by the time this bodyguard gets back to the boat, these 2 presidents will be dead. So the problem specification tells us where we have to start. We will be going from everybody on this side of the river to some intermediate step. All we can do is send the presidents across the river. Now, I'm not going to lie, but we know that we will pass through this intermediate position. 2 presidents will go across. There'll be 1 president left here, but that president will be with their bodyguard, they'll be fine. We leave a president over here, 1 president brings the boat back, they're going back to be with their bodyguard, they're okay. Now, given what we know about the symmetry solution, and as we did here, once you find your midpoint, everything after that is just a reverse of everything that got you there, right? So if we have this intermediate point, it gets us from 3 of them on this side of the river, doing it on this side, remember? Whatever steps we conduct in here will be reversed here. But it follows that because it's the reverse, because we know we're dealing with a mirror symmetry. So we have already decomposed our problem into 3 parts. We have some sequence here that gets us from our starting position to here. We have a sequence here that gets us from this to this, which we know will be the reverse of this. But then we have this one, where we get from here to here. Well, if the first part is symmetric, and the second part, the third part is symmetric, we'll go with that and assume that our sequence 2 is probably also symmetric. So, what might we expect to be in the middle of that middle part? Probably the most symmetric configuration of a problem domain that we can have. So somewhere in here, now we don't know yet whether we're going from the right hand side of the river to the left, or the left hand side of the river to the right, or it's as symmetric as our relation can get. I think that's enough of that. Let's just get started. Have a go.
Will the bodyguard feel known as events if they are with their child?
Well, the bodyguard do what?
Will the body feel known as events if they're with their charge?
You didn't finish, bro.
Bodyguard
Yes,
is in the event bodyguard president.
How could it not? Because I was hoping you have to write down a BBC. Dude, it's not CDD. It's BBC people. Oh no. Why'd you save it, Jim? What are you doing with your life? You're gonna go and jack your shit to picture me, aren't you? You freak. Yeah, you said that to anyone else. You said that to anyone else. Why would I say that to anyone else? Are you sure you just said this is a gentleman? Bro, why would I say this to you? What is wrong with you? That guy said that to you, Jack. What? No, what you gonna do? I'm gonna go and take a picture Bro, just know, yeah, when we start like snapping the picture like when David started, I'm gonna crash out and sit down. Yeah, I'll go change that to profile picture and then you got the check from
So, okay, people are still working on this, so I'm not going to answer it now. So we'll give you a different question for now instead, and leave you to play with that until then.
वीकली वाला क्वेश्चन वेडनेसडे के लिए या ये अभी क्वेश्चन जो मिले
अभी एक और बताएंगे
जो वेडनेसडे के लिए
जो अभी हम लोग
ओके
ये
वेडनेसडे के लिए क्या वेडनेसडे के लिए भी ये
This may or may not be obvious looking at it before.
पूरी क्लास करना क्या
इसके बाद सांस से उसके बाद बात
कौन कर रही है
हाँ मतलब
You think a site engineer would have thought to check if the microphone's on? So, before I came to UCD, I was a sign engineer. I used to get paid to go to gigs. It was not the worst job I've ever had. Very antisocial hours, but it was a fun job. But there's a kind of problem that could come up. Say I have a microphone set up on stage, and it's 15 meters from the stage box. The stage box is a box that's on stage where you can plug in all of your microphones so you're not running cables across the floor. You don't need to worry about what a stage box is, it's not important. I have a microphone set up on stage, and it's 15 meters from where I have to plug it in. Problem is, I only have 8 10-meter cables. And the other part of the problem is that 4 of them don't work. So the only way for me to get a signal from that microphone is to connect 2 working cables end to end and plug them in. Now, what is the minimum number of connections, worst case scenario, that I have to make to find 2 working cables? You can't tell looking at a cable whether it works or not. But if you've tested 2 cables, you know what cables you've tested. Yeah.
What bands did you sound engineer for?
Nobody thinks.
Close to you guys?
Yeah, but they just never made it. They should have kept me the same. Yeah.
Could you repeat the question?
I have a microphone.
Wait, you want to find which one's working? You want?
No, what's the minimum?
15 meters.
No, he
from
wants
where
the
I plug it in.
most. He wants the most connections
Problem
you have
is,
to make.
I only have 10-meter cables.
I hope you guys
I have
scored
8 10-meter cables.
22
And then I
minutes.
remember, oh damn it, 4 of these don't work. So what I want to know is, how many times do I have to plug 2 cables together to find 2 that work? And I can't assume any good luck. So if
4 of them don't work.
4 of them don't work.
How many cables do we have?
8.
8?
What if like 8C1 or something? 8 choose.
I wish this solution had occurred to me when I still needed it. Yeah.
Why is free giving your wallpaper?
Yeah, it's not like it was plugging into the same box for the microphone.
No, that whole process will come to one application. So plugging one end into the bottom of the microphone, cable on the end of that, and the other end of that into the stage box.
I was just too locked in. Why'd you look so locked in? You're like,
Wait, did you get the notes or
Well, exactly. I still wouldn't get a signal. That's right, 4 of them don't work. There's no way of looking at
nah, you're not. Why did you go out
plug in one end of the cable into the microphone, connect it with the cable, you got it and one plug in anywhere to disconnect.
You're so distasteful.
You get the invite to do
No, I would have got it from 80s or whatever. Oh, yeah.
I'll run quickly through the most obvious solution, and then tell you how much better we can do.
Is the best thing
So, Let's say we try our first cable. We just pick one at random,
Yeah.
plug it into the microphone. Now we have 7 other cables to test it with. Now, if this works, then 3 of these work. Let's say we test this, we get no connection. We can conclude cable A is no use. Then we try cable B. Now there are 6 left. And again, if none of these work, this doesn't work. And we got the same for cable C and cable B. 7, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4. How many tests does that add up to? So 7, 6, 5, and 4. Okay? Plus this one. Because we isolated our 4 working tables. Yeah. Alright. However, so we can abbreviate this slightly. When we get here, if this one works, then 3 of these work. So if cable D with the first other one we test doesn't work, then we know these 3 have to work. So once we test D with any one of these, if we don't get a signal, we know it doesn't work. So that needs only be 2. And it's the same here. If this one works, 3 of these work. So once we get to this point, if this doesn't work with this, so we can shave 2 off all of these, which gives us 9, 12, 14. You can do it with either.
I think I got it.
Okay. What time do we have? I'm going to show you how to do it in 8. And then I want you to do it in 7. What we do is, we split our cables into 2 groups of 4. Okay? We then test them pairwise. Right. What do we learn if the pair A and B doesn't work? At least one of A and B doesn't work. And it's the same when we test C and D. At least one of C and D doesn't work. Then we test those 2. At least one of A and C doesn't work. And at least one of C and D doesn't work. Alright. At this point, we've learned something. If we still haven't got a working cable out of it, say one of these cables work, would we get a signal out of any of those pairings? No, because if it's only one of them, the cable it's being connected to is a broken cable. What if 2 of them work? If 2 of them work, we'd find a good connection. Right? So we know at least 3 of these don't work. Which means we come to this line. If 3 of these don't work, 1 of these doesn't. So 2 tests over here, we've found it. And that is 1, 2, 3, 4, 5, 6, 7, 8. I'm going to leave you to work out how to do the 7. And again, you're not assuming any luck. It's 7 that will guarantee you will find 2 working cables. So you can do that for Wednesday, and you can think about that just for fun. And anybody that is wanting to review functional programming, I'll be upstairs at E117, 1 o'clock.